afternoon, everyone. My name is Bhushan Rokade, and I am a third year student at Dr. Bhushan Institute of Technology. So, I am going to present today our mini project that we have done as a fifth assignment for SMD. SMD stands for Software Modeling and Design. So, my teammates are Aditya Wagmare, Vinayak Pedi, and Kedar Bhargave. So, let's get started. Our first topic is the state machine diagram. So, what is the state machine diagram? The state machine diagram represents the flow of the system by using the states, transitions, and other components such as fork, join, um, and state, final state, and initial state. So, here is an example of state machine diagram on an online book store. So, as we can see here, this one, the field dot, is the initial state, and this arrow is the transition to the next state, which is logged in. So we can see from the initial state, the user is logged in into the system. He is reading a book. He is reading the book details, and if he likes that book, he will go and check out. And if he doesn't, he will read another book. And after checking out, he will pay for that book, and after that, he will just log out and reach the final state. Whenever a user reaches a final state in the state diagram, that means the flow of the system is over and he cannot go any further. So after that, we have the second topic with us, the component diagram. So component diagram. So component diagram is a part of UML. UML stands for Unified Modeling Language. In this diagram, we just divide up the system into independently functional parts called as components, and we just connect those components and describe the system. So there are four components for the component based diagram. First is component, second is interface, third is relationships, and fourth one is nodes. So there are 5 steps to creating a component based diagram. So at first step we should identify the functionalities of the system. In the second step, by identifying the after that identifying the functionalities of the system, we will divide the system into multiple functional components. After that, we will just define interfaces which are useful for the components, and then draw the components. The component is represented by a rectangle, and at the right side of the marking of that rectangle, there are two small rectangles. So after drawing the components, we will just connect the components using the relationships such as dependency, aggregation, and etc. So here we have an example of component diagram with us for an ATM machine. So there are, as we can see, there are many components comprised of the ATM machine. The ATM machine itself is a component. After that, checking the balance, withdrawing the money, choosing a language, entering the card, entering the PIN. These are all the components that make up the ATM machine. And we can see that these components are connected with each other using relationships, such as relationships called dependencies. That means the components are dependent on each other. The fourth one is class diagram. So the class diagrams are a part of UML. UML is the Unified Modeling Language. As we can see, we can divide the system into uh, separate entities and call those entities as a class diagram. The class diagram just shows the structure and represents the relationship between classes within the system. So we have the UML class notation. There are three components for class notation. The first one is class name. The second one is the attributes, and third one is operations. There are there is a specific name for every class that's called the class name. Second one is attributes, as we know. Attributes are the properties or attributes are the properties a or a something that describe the information about the class. After that, we have methods or operations. Methods or operations are the behavior of the class that the class can perform. As we can see, the bank is the class name for the bank class. Code and address are the attributes which gives us the information about this class, and manages and maintains are the operations of the class. Bank maintains the ATM and bank manages the debit card. As we can see, the second class called as ATM transaction. So ATM transaction has three attributes. First is transaction ID, the date and the time. These three attributes just give us information about that ATM transaction, and the operation for that class is update. So we can update the ATM transactions. We can update the account balance and everything using that ATM transaction. So these classes are connected with the relationships known as aggregation, the generalization, and dependency as well. So here we have used the aggregation dependency and the generalization as well. So the generalization basically includes the inheritance into the class diagram. So as we can see, the ATM transaction can be comprised into two separate classes, which are withdrawal transaction and transfer transaction. So these two classes have their attributes and operations of their own. So as we can see, the withdrawal transaction and transfer transaction can be generalized into one class called as ATM transactions. So that is it. Thank you.